Hi friends, is my voice is audible to you? My voice is audible, and if everything is fine, please let me know. Right? Yes. 1 second. Think, think. Uh, I just want to know how many of you people are in online so that I will understand. Right? Okay. Is my voice is audible? Right? Uh, just I want to know how many of you people are in online. Okay. If you are in if you are in online, please say hi so that I will understand. Right? Yeah. Okay. Okay, guys. Today's the session is all about limit state of Flexure-5. Today I will tackle mostly about doubly reinforced sections. Yesterday I started doubly reinforced beams, na? So I will work out the doubly reinforced beams today. But before I start the session, I just want to convey there is so much of free content is already happening in Unacademy Learning app. So if you are a serious aspirant of GATE or ESE or any other competitive examination, right? So please, I can recommend you to install this Unacademy Learning app, definitely. So because so much of free content is already there, right? So people will also ask us how to install that one. Go to Play Store, and after you go to Play Store, type this name Unacademy Learning app. When you type this name Unacademy Learning app, right, you are able to install this one. You are able to install this one. After you install this Unacademy Learning app, now you can follow me using this link which is shown here. I hope you can follow me using this link in Unacademy Learning app, right? Okay. So before I start the session, I just want to convey. I asked you to install the Unacademy Learning app, na? So after you install the Unacademy Learning app, keep the target as GATE and ESE. And there are paid courses also in Unacademy Learning app, especially in GATE and ESE category. That paid course we generally call it as take subscription. When you are interested to take the paid course, which is nothing but you can take the get subscription. After you can go to this GATE and ESE, right? Yes. So I just want to convey one more thing. When you had taken this plus subscription or get subscription in Unacademy Plus, unlimited access of live and recorded courses from India's best educators, you will definitely get. So I can recommend you to use this Unacademy Learning app. So by the time while you are using this taking subscription, use the code VT10, then definitely 10% discount will directly come to you on all the courses on Unacademy Learning app, brothers. So some people will say like, sir, this is our new class, actually first class. So please introduce about yourself. I am Venkata Tilak. People call me as Venkata sir. Some people call me as Tilak sir. I completed my master's degree from University of Sheffield, England, and about to complete my doctoral degree, which is PhD also. My background of education is completely into structural engineering. So here also in an academy, I am going to tackle only structural engineering subjects, ranging from engineering mechanics, strength of materials, structural analysis, concrete structures, steel structures, and finally to construction materials and management. Totally 6 subjects I will tackle. Some people will also ask us, sir, what about the specialty of this university from where you had graduated? This university has produced 6 Nobel Prize winners. I hope you can understand that. One thing. And second thing is, this university is far better than IITs and IIC Bengaluru. If you see the rankings, global rankings of universities in entire globe, right? That is the second thing. That is second important thing when you see about this university, right? Some people will also ask us, sir, okay, what is your previous experience? Previously, I worked as research scientist or research engineer in University of South Carolina, which is in USA. And previously, for this project, for in this University of South Carolina, I worked as team lead also. By the time I am working as research engineer, I led the team of research team there. Right. Uh, in addition to this one, previously I worked as head of the department of civil engineering also in an engineering college in Andhra Pradesh. This is my previous work experience in addition to teaching. In coming to teaching, I have 12 years of teaching experience in teaching GATE and ESE in different coaching institutes all across India. Right. Being a structural engineer, even till today, I am working as an independent structural design consultant. I personally do structural designs on my own. I provide structural drawings to my clients. And I provide material testing report also to my clients. There are two things when these are two things I do in addition to teaching right now. Okay, I can convey you if you are really interested to take a paid course, then definitely I can recommend you guys to to use this code VT10. When you are able to use this code VT10 directly, 10% discount will come to you on all the courses in an academy learning app, in an academy plus. Some people will also ask us, sir, how to purchase that course after you install this Unacademy learning app. Na, go to. I hope you are able to see in this. This is the target what you want to achieve. This is the goal. Select this goal as GATE and ESE, and this is the drop down menu. In the drop down menu, go to plus courses. After you move to plus courses, right? You in the search button. After you move to plus courses in the main menu, in the search button, you type my name, Venkata Tilak Uppalapati. And if you enter after typing my name, definitely my profile will be visible to you. When my profile is visible to you, just you I mean after you type this name, you can follow me. And after you type this plus courses, now I can also convey you like, after you type this plus courses, you can take this get subscription. When you use this get subscription, after you go to plus courses, then you are able to pay the fees, maybe in terms of monthly installments or maybe in terms of all the direct payment at a single time. This is how you can do. Some people will also ask us, this is sir, is there any other way how you can follow, how we can follow you? This is the link, if you press over this link, definitely it will redirect to my page, brother, so you can follow me. So some people will also ask us, right, sir, if we had taken the paid course or subscription, okay, in an Academy Plus platform, right, what I will get, how it will be different when compared to, I can say, free users, right? So the first and foremost thing is every daily live classes you will get. When you got this daily live classes, I can definitely say like when you get this daily live classes, uh, the educator, you can chat with the educator, and the educator will resolve all the doubts regarding to your subject, right? That is the first and foremost advantage. Coming to the second advantage is, so in addition to instant doubt clarification, test series support is also required. We are here at an academy, we are providing test series support also. By using the test series support, you can evaluate your performance, and after you evaluate your performance, you can understand at what level you people are when compared to the topmost students of an academy. And if you need to improve in some of the areas, you can watch more number of video lectures in that particular area. And I can say in addition to that one, I can say if you want to improve your performance, you can improve your performance, and you can write more number of tests in that particular area to improve your performance again. And third one is, all the courses that are provided by an academy are completely structured courses, brother. Right? There is no need to plan yourself. Everything we will provide the plan. If you follow that plan, definitely you are able to achieve the success. And coming to the syllabus in that structured courses, we keep the syllabus in mind as per the latest examination syllabus of GATE and ESE, and we will prepare the schedule for you. Just follow the schedule and follow the structured course. After you listen to the course, and after you are able to work out all the quizzes, tests, series that are provided by an academy, definitely we are pretty much sure you are able to crack any sort of competitive examination with very good rank. That is the third, what I can say, third advantage. And coming to the fourth advantage, like, let us suppose Vatan Sai is not able to come down to live class on one day. In such case, Vasant Sai is provided with the same lecture in the form of recorded version, right? I can say. Uh, in the form of recorded version, he will be provided with the same lecture with the help of maybe mobile phone or with the help of maybe smartphone, or else he can access the same lecture by using a tab or maybe PC, or depending on the comfort of his interest, his or her interest. Okay, right. These are some of the topmost indicators that we have. You can have a directly look at them, and the courses. If you want to get 10% discount in an Academy Plus platform, you need to use this code BT10. When you are able to use this code BT10, directly 10% discount will come, and this is the link that you can follow me. When you follow me, the advantages are the future coming videos will be notified to you in terms of free courses, and already done free content of mine in an Academy learning app you are able to access when you follow me. And the third advantage is at the end of each and every session we generally provide a PDF notes also, right? After I can say with the help of that PDF notes, definitely you are able to achieve some of the content in the form of notes, right? So these are the three advantages when you follow me, right? I just want to convey one more thing also. These classes will be held separately in English and also in Hindi medium. So there won't be any language barrier also. If you are comfortable in English, you can listen to English classes. If you are comfortable in Hindi, you can listen to Hindi classes also. There won't be any language barrier also. Right? And when you have taken subscription, you will be provided access to all the courses in that particular stream. Some people especially will also ask us, like sir, in GATE and ESC, especially in civil engineering, how many courses you people had launched? Till now in GATE and ESC, in civil engineering, we people had launched 8 courses totally. As every month pool of faculty are going to get increased, I can definitely say like easily the number of courses will also get increased every month by at least one course. So when you had taken subscription, you will be provided access to all the courses in that particular stream. So please be aware, right? And if you are interested to join any of the courses, right, paid courses, then you are free to use this code BT10 in an Academy Plus platform. In an Academy Plus platform, right? Right. Ambar Datta. Hi, Ambar Datta, bro. How are you? One second. To drink some pail of water. Right. I hope you guys are fine. Right. So, yes, coming to 12 months course. Let us suppose if you want to join for this 12 months course. In such case, we can the cost is around 27,225 after 10% discount, and you are free to use this code BT10 to get 10% discount. If you don't use this code BT10, then you will not get 10% discount, bros. And if you are in second year or third year student, then definitely I can recommend you this 24 months course, which costs you around 39,600. And some people feel like this cost is high, but you can pay, but it is very simple. The payments are there in terms of installment. So I can recommend you, if you are not able to pay at a time, you can also pay the same thing in terms of monthly installments also, right? Yes, Amber bro, how are you? Hope you are fine, right? Right. And I just want to convey one more thing also. Like every day, my class it will happen in an academy in Let's Crack Gate and ESC Civil YouTube channel. My class will happen every day by 11 a.m. So don't miss that one. I can recommend you that. So definitely you will get something very well. Definitely to crack Gate or ESC or any other competitive examination. So, and I want to convey one more thing. I already started a Telegram group, and the name of the Telegram channel is Unacademy underscore Civil Engineer Tilak. If you want to join to that Telegram channel, brother, then I can recommend you like you can use this link. If you use this link which is given below Unacademy, I mean HTTPS same thing Unacademy underscore civil underscore engineer underscore Tilak. So please understand the C is capital, E is capital, and T is also capital. So if you press down this link directly, it will redirect to my Telegram group or channel. So whatever may be the doubts, if you have, you are able to post your doubts directly in that Telegram group. So I will definitely respond to your doubts, right? Right. And more notifications about the coming lectures will also be notified to you. Right. So shall we start the session? In your previous session, we started this doubly reinforced beams. In this doubly reinforced beams, in your previous session, we teach you what is the need, what is the double reinforced section. I teach you when we can go for double reinforced section also. I teach, right? Yes. And I just want to convey one more thing, like, sir, how we can design for a double reinforced beam. So I can say, like, this is a double reinforced beam. How you can convert a double reinforcement if mu is the bending moment due to external loads. If mu is the bending moment due to external loads, I can say from structural analysis program, you can work out the bending moment due to external loads. And if mu limit is the moment of resistance of a balanced singly reinforced section, and I hope you know the formula directly. Formula for different reinforcing steel grades are derived, right? I hope if you know, if for FE 415 it is 0.138, MU limit is 0.138, FCK BD square. It is for FE 500, it is 0.133 FCK BD square. You are able to work out this, right? Isn't it or not? You are definitely able to work out this, right? Some people will also ask us, sir, okay, now the question is how you can design for a doubly reinforced section. First of all, how you can design. So if the total moment to be resisted by a doubly reinforced section is mu, when you can go for a doubly reinforced section, brother, when mu, one second, when mu is greater than mu limit. In such case, definitely I need to go for doubly reinforced section. When mu is less than limiting moment of resistance, in such case, single reinforced section itself is sufficient, right? This is what you learned from your previous class. Okay. Now the question is, okay, sir, we want to go and we want to learn about the design of doubly reinforced section. Okay. So how we can deal about the design of doubly reinforced section? For the design of doubly reinforced section, design of doubly reinforced section. In the design of doubly reinforced section, what is the data that will be included? The data that is included is the bending moment that should be resisted by the section. Maximum factored bending moment developed due to external loads. Due to external loads, right? And if the width of the section, like b, small b, and overall depth, maybe if small b is width of the beam, small d, capital D, overall depth of beam. And if you say cover, I hope you can say it may be clear cover, or if it cover maybe clear cover, maybe clear cover, and T dash, which may be effective cover. All these will be given. And FCK, the grade of concrete, and yield strength of steel, the characteristic yield strength, the characteristic strength of steel, these two are already given. So if these are the given parameters, in the design of double reinforced section, I just want to convey 1 second. In the design of double reinforced section, dear Ambardatta Pro, you tell me what is the things generally we will design for double reinforced sections. In design of double reinforced sections, we will generally work out the design means we will work out area of steel. Here the steel area will be in tension zone and steel area in compression zone. So design of doubly reinforced section means if the section sizes b and d are given, the remaining things what I can work out, maybe 1 second, I can clearly 1 second, I can clearly say like design indicates need to work out tension steel and compression steel, right? Tension steel and compression steel. So I need to work out AST. AST stands for tension, area of tension steel. ASC stands for area of compression steel. I need to work out. I need to require to calculate these two. So how to work out this design of doubly reinforced section? These are the two parameters I need to work out. So okay, some people will also ask us, sir, how we can do that. So I will follow these three steps. I hope maybe four to five steps which are given here. If I follow those 4 to 5 steps, definitely you are able to work out the design of doubly reinforced section. Okay, now the question is, sir, let me erase this thing and I want to tackle about these steps that are included for the design of doubly reinforced section. Okay, so the step one is moment of find out the moment of resistance of balanced section. How you can work out the moment of resistance of balanced section? Limiting moment of resistance, which is equal to some value times of FCK BD square. This we already know. We are able to work out this, right? Let us suppose if MU is the, I can say, maximum factored bending moment, or which is equal to design bending moment in structure. What is design bending moment in structure? It is the maximum bending moment developed in structure. Okay. If MU is less than MU limit, then I can say only singly reinforced section is sufficient. Then design for SRS means singly reinforced, singly reinforced section, right? If MU is greater than MU limit, in such case I need to design the beam as doubly reinforced section. DRS means I need to design for doubly reinforced section, right? Yes, Ambar Datta, bro. You need to work out tension reinforcement, and after that compression reinforcement, you need to work out. So first of all, to say whether I need to design for singly reinforced beam or doubly reinforced beam, you need to check for MU and MU and MU limit. Compare these two. When MU is less than MU limit and when MU is greater than MU limit, compare. So different types of beams we can design. Now the question is, sir, okay, what is how to work out this AST? Total AST is equal to AST1 plus AST2. So now everybody will also ask us, especially Ambar Bro or Vasant Sai will ask us, sir, what is this AST1? What is this AST2, sir? Right? First of all, please explain those two. Yes, I am going to explain first how I can work out total area of steel and tension zone. I just want area of steel in tension zone, and ASC is area of steel in compression zone. Right, this is how we can this what we need to work out now. Okay, so now the question is, sir, to work out total area of tension steel, it's a combination of AST1 plus AST2. So let us suppose the let us suppose the section is a doubly reinforced section. When the section is a doubly reinforced section, it needs to resist a moment of MU, right? No doubt at all. If MU is the moment of resistance, MU is the moment of resistance to be resisted by doubly reinforced section. Take this section can be classified as a combination of two sections. One is a singly reinforced balanced section. I hope you are able to see. This is a balanced section with singly reinforced balanced section. This is a balanced section, singly reinforced balanced section. So for singly reinforced balance section, the moment of resistance is ultimate or limiting moment of resistance, definitely. MU limit. We can call it as MU limit. Then the remaining steel, both in compression steel, this is a, there is no concrete is there. Concrete is already over. Only somewhat some steel in tension zone and some steel in compression zone only. So I hope, let us suppose this section is able to resist mu limit. So what is the remaining moment to be resisted by the compression steel and the remaining tension steel? I just want to convey AST1 is the area of steel corresponding to which section, man? Corresponding to balanced, singly reinforced, balanced, singly reinforced section with moment of resistance. What is the moment of resistance? With moment of resistance is mu limit, limiting moment of resistance. Okay, and second, next thing is what is the remaining moment that needs to be resisted by compression reinforcement, brother? So there is only compression reinforcement I need to provide. Let us suppose I had provided, brother, here compression reinforcement. I hope clearly you are able to see here compression reinforcement. I hope. Yes, this is how I have provided the compression reinforcement. After I provide compression reinforcement, to compensate this compression reinforcement, almost similar tension force should come. So in tension zone, some extra steel I need to provide. This is the extra steel that I had provided. So which can compensate this compression force C2, right? So I just want to write what is AST2. AST2 stands for, I can write steel required, I mean tension steel, I can say better. Let me write here uh, tension steel, tension steel required to resist extra moment. What is that extra moment? Extra moment is equal to mu minus mu limit. Right. So to resist a moment of remaining mu minus mu limit, the tension steel that we had kept is AST2 and the compression steel that we had provided is ASC, right? So I just want to mention those two. So let me mention the definition of ASC also, area of steel in compression zone. So how you can see ASC, area of steel in compression zone, I can say definitely. So okay, how you can define this ASC? ASC is the area of steel in compression zone. Steel required in compression zone to resist a moment of mu minus mu limit. Steel required, steel required, steel reinforcement required in compression zone. Steel reinforcement required in compression zone to resist moment. What is that moment? Mu minus, I can definitely mu minus mu limit. I can write that. Okay. So now everybody will also ask us, sir, how to work out this AST1, how to work out this AST2, how to work out this ASC. These are the three things generally everybody will ask us, right? So I just want to say that one with the help of equations, right? So I just want to show, right? Let us suppose if I want to work out this AST1, AST1, what is this definition of AST1? Steel required for a balanced section which is balancing concrete in compression zone. Steel which is balancing concrete in compression zone, that steel is the steel required for balanced section. So how to work out that AST1? That answer is that moment of resistance for balance section is mu limit, and the answer will be tension force into lever arm. So what is the tension force that is resisted by this AST1? So I can write 0.87 Fy into AST. This is the tension force AST1, tension force. This is 0.8 permissible stress in tension zone. Permissible stress of steel in tension zone is 0.87 Fy at the time of at the time of limiting moment of resistance. Tensile steel will get yielded. So the design stress in steel at the time of tension steel has got yielded is 0.87 Fy. This is design stress. This is design stress. And AST1, the area of steel corresponding to balanced failure is AST1. This is tension force. This is lever arm. And lever arm, how you can say about lever Leveram is, I hope you can say D minus 0.42 XU. But for a balanced section failure, XU is equal to XU max. Na? So that's the reason why we are working out this as D minus 0.42 times of XU max. From this one, you know MU limit. I hope from this equation, this is MU limit. From this equation, if you take this as the equation, right, I hope you know this mu limit answer. This is known. 0.87 F5 value is known. D value is known. XU max. I hope you can work out XU max directly we had derived. Whether it is 0.53 times of D, 0.48 times of D, 0.46 times of D. This is for FE 250, FE 415, FE 500. We had already derived this. So that means even I know this XU max. In this equation, maybe I can take from this equation. If you take, maybe if I do a box, if I take this equation, from this equation you tell me what are the one and only one unknown. AST1, I hope clearly here, AST1 is the one and only single unknown, right? From one equation I can work out one unknown. So from this equation I can say like AS, area of steel in tension zone, AST1 is obtained. I can work out that, right? So in the total area of tension steel, AST1 I worked out. I need to work out AST2. So this is over. I hope you can say this is over. I need to find out this, which is AST2. I need to work out. Now the question is, sir, what is this? How to work out the AST2? Everybody will ask us, right? So how to do that, brothers? So first of all, if you understand the meaning of AST2, the problem that we can work out. AST2, steel required for extra moment, and the magnitude of that extra moment to be resisted is Mu minus Mu limit, which is equal to the tension force, which will resist a moment of Mu minus Mu limit. So what is the tension force? Here, the tension force T2 that will resist a moment of Mu minus Mu limit. How we can write this tension force T2, brother? From this one, how you can write? Maybe if I rub the screen here, if I screen this is all dotted. This is only pure concrete. Here I can say no concrete, only compression steel ASC and tension steel AST2. So AST2, how you can write AST2? AST2 is the steel required to resist extra moment, which is equal to Mu minus Mu limit. Okay, right. You can work out this AST2. How you can work out this AST2? So the moment to be resisted is Mu minus Mu limit, that is equal to the corresponding tension force is to resist a moment of mu minus mu limit is T2. So I can write T2 into the lever arm between compression force C2 and tension force T2 is L2 into L2. So how you can write this tension force T2, brother? This tension steel is yielded, right? Because the tension steel AST1 has yielded, so definitely AST2 will also get yielded. So the design stress is 0.87 times of Fy, I can write. And coming to the slave ram, how you can work out the slave ram? Already the effective depth is D, and this effective cover is D dash. D dash is the effective cover, I can say uh, D dash. This is D dash. This D dash is the effective cover from here to here. This is D dash. D dash effective cover in compression zone. So if you want to work out this L2, I can write D minus D dash, isn't it or not? So I can write this is multiplied by D minus D dash, isn't it or not? Right. So this is sorry, I just want to convey this is only the stress multiplied by area. What is the area in what is the area in tension zone that will resist a moment of Mu minus Mu limit? The area of steel in tension zone that will resist a moment of mu minus mu limit is AST2. So I need to write AST2. Design stress into AST2 into lever arm is D minus D dash. So I hope you already know mu, you already know mu limit. So that means I just want to convey in this equation, this mu minus mu limit is known. 0.87 known, Fy is known, D is known because that is given in the problem. I hope you can see. D is given in the problem. And D dash, effective cover of compression zone is also given in the problem. Right? So the one and only unknown is AST2. So from this equation, definitely I am able to work out AST2, right? So the same thing. So this is another equation. In this another equation, only single unknown is there. As only single unknown is there, I can work out that area of steel in tension zone AST2, right? So this is how you can work out AST2. So just to teach, to show you how we got this one, I just to show you this lever arm L2, I had taken the help of this, what I can say, this figure. So that's the reason why I came down to this slide, else it is not required. So to write these equations, everybody will also ask us, sir, how you had written this equation. So from the for a moment of mu minus mu limit, I need to use this the this sketch. To resist a moment of mu limit, I need to use this sketch, right? So okay, right. So AST2. So from this one, which is Fy is known, Mu minus Fy is known, 0.87, D minus D dash is known. The one and only one is AST2. You are able to work out AST2 is uptight. Now everybody will also ask us, sir, what is the total steel in tension zone? Because we had converted the problem into combination of two diagrams. The area of steel in tension zone, which will resist a moment of mu limit is AST1. What is AST2? That will resist a moment of mu minus mu limit. This is the difference between AST1 and AST2. If you add up these two, AST1 and AST2, directly you are able to get total area of steel in tension zone. Is that okay? Right. That means you are able to work out total area of steel in tension zone. Now, especially Ambar Datta Pro will ask us, sir, okay, the remaining part I need to work out in the design is area of steel in compression zone. If ASC stands for area steel area required in compression zone for resisting a moment of mu minus mu limit. So this is the moment that I need to work out. So this must and should be equated to moment of resistance. The moment of resistance for is mu minus mu limit. So how you can write? I want this area of steel in compression zone. So that means I need to use compression force. What is the compression force in? I hope you are able to see. What is this compression force here? C2. Maybe let me rub the screen. So what is the compression force C2, which will resist which will which will resist a moment of mu minus mu limit. So that moment to be resisted is mu minus mu limit, and to get this compression force C2 into picture, I need to write C2 multiplied by lever arm L2. How to work out that compression force C2? So maybe I can say the stress in compression steel. So when tension steel is yielded, compression steel need not be yielded. May be yielded or may not be yielded. So I don't know. C2 stands for compression force in compression steel, right? So maybe I can write compression force in which steel, man? In compression steel. How we can write this? Generally, this compression force in compression steel, we can directly write, which is equal to stress in compression steel multiplied by area of steel in compression zone. So I can write stress in, developing stress in compression steel, stress in compression steel multiplied by lever arm L2. So how you can write that stress developed in compression steel? I can write the stress as F, FSC. Stress developed in compression. C stands for compression. S stands for steel. Stress developed in compression steel. FSC into this multiplied by area of steel in compression zone. So I can write into ASC. This is the compression force developed in compression steel multiplied by lever arm. What is this lever arm L2? Already this is D. So if I want to work out this depth, which is already d minus, this is d dash. So I can write lever arm L2 is d minus d dash. So if you see this equation, mu minus mu limit, mu minus mu limit, I just want to convey one thing. This mu minus in this equation, if you take this equation, generally, if you refer to code of practice, uh, uh, from based on T dash by D, we are able to work out stress in compression zone, and even the stress in compression zone will also be given. This will be given. Don't worry. This will be given in the problem, and D minus D dash is already known. Mu minus mu limit is already known. So from this equation, the one and only unknown is area of thin compression zone is the unknown can be worked out, right? So that is the next step. So the same thing, to write this equation, you require this stress, you require this compression force C2 and tension force C2. So that's the reason why I just had gone there. One second, I just want to show, like, so mu minus mu limit is equal to compression force C2 into L2, lever arm L2. What is that compression force C2? Stress in compression steel, FSC, into area of steel in compression zone, ASC. So maybe I can write ASC, area of steel in compression zone, right? So the lever arm L2, the lever arm L2 is D minus D dash. Right? This is known to me, and FSC into ASC is also known to me, right? So from this one, FSC is stress in compression steel. All generally, if I want to work out this one, you can work out from IS 456. Generally, in competitive examinations, this FSC value will also be given. I can say stress in compression steel is nearly equal to 0.87 F5, assuming I can say this answer as 0.87 F5 if the compression steel is yielded, then the steel in compression zone will also reach to definitely yield stress. So what is the design stress? F5 by factor of safety, which is 1.15. So in such case, that stress in compression zone after applying factor of safety, which is nothing but design stress, is 0.87 times of F5, assuming the compression steel is also yielded. So from this equation, this is mu minus mu limit is known. FSC is known. The one and only unknown is ASC. So from this equation, I can work out ASC can be worked out or found out. Okay, this is how we can work out. No. So this is all about the design process, right? So shall we work out the analysis also? What is analysis? Analysis, if the cross section of a beam of doubly reinforced section is given, yeah, I need to work out the depth of neutral axis, and I need to judge the type of section, and if I am able to find out moment of resistance of the section, though all these three parameters comes under analysis part, like, so let me show here analysis. So in analysis means what? Analysis means finding actual depth of neutral axis, I can say, and maximum or limiting depth of neutral axis, and judging the type of section. Actual depth of neutral axis is XU. Limiting depth of neutral axis is, maybe I can say, as uh, XU max. How you can compare, how you can judge the type of section? By comparing XU and XU max, I can come to a conclusion whether it is under reinforced, over reinforced, or balanced section. I can come to a conclusion, right? Yes. So some people will also say like, okay sir, and in addition to this one, what else you will work out? And I will also work out moment of resistance of the section, which is equal to compression force into lever. So by the time I'm working out from the basics, is the compression force, total compression force into lever arm. Shall I use only XU or shall I use XU max? That depends on the type of section. So that's the reason why after working out this one, I can work out the moment of resistance of the section, right? So in the analysis part, what will be the given terms? The given terms in analysis part is the width of the section, like this is B. Width of the section will be given. The overall depth, I hope you can see. The overall depth D is given. And this D dash, what is this D dash? D dash is effective, I can say effective cover in compression zone. So this will be cover in sense clear cover. Cover is given. So B is given overall depth D. I hope you can say overall depth. Small d effective depth, which is the distance between extreme compression failure to the centroid of tension steel, which is this is the centroid of tension steel, right? So this is effective depth small d, right? Uh, so when this overall depth is known to me, I am able to work out. When the overall depth is known to me, I am able to work out effective depth. Effective depth can be worked out. Let me change that color, brother. Effective depth can be worked out. Okay, right. Just after I do, these are the givens, and they will give you what is the area of tension steel AST, what is the area of steel in compression zone ASC. These two will also be given. AST and ASC will also be given, and I can say I need to work out even FCK. What is that FCK? I need to work out the grade of concrete and grade of steel F5 and stress in compression steel FSC. These three values are given. FCK, maybe I can write grade of concrete F5, grade of steel FSC. I can say stress in compression steel, present compression steel. All these three will be given. So if for to work out this analysis means is I am required to calculate the moment of resistance, the actual moment of resistance MR. I need to work out MR, right? So which is moment of resistance. Either I can write tension force into lever arm or compression force into lever arm. Something I need to work out. Either compression force into lever arm or tension force into lever arm. Any of these things are okay. So in this analysis also, I just want to say in terms of steps. Maybe I will teach you, not maybe, I will teach you 5 steps. If you are able to follow those 5 steps, brother, definitely we are pretty sure like you are able to work out any problem in double reinforced section also. Is that okay? Right. So I just want to rub the screen first. Okay, coming to this step number one. What is in step number one? You need to find out the limiting depth of neutral axis or maximum depth of neutral axis. So I hope you are able to find out XQ max. Let's say find XU max uh, based on the grade of steel. I hope you know when it is Fe450, you can work out XU max 0.53 times of D. This is already worked out for Fe250. For Fe415, it is 0.48 times of D and 0.46 times of D. It is Fe500. You are able to work out all these things in this way, right? That you already know. Okay. So what is step number two? Coming to step number two, I need to find out. Need step number two. Need to find the actual depth of neutral axis. How you can find the actual depth of neutral axis? Always the actual depth of neutral axis can be worked out from compression force. Total compression force is equal to total tension. Coming to total compression force, the combination of compression force C1 plus compression force C2 is equal to T, right? We can write in this way. Now coming to this compression force C1. So coming to this compression force C1, I hope you already know coming to this compression force C1, here it is a single compression force because of a singly reinforced section. What is that compression force C1? We can write here we are interested to find out the actual depth of neutral axis. So I can write total compression force C1. I can say it is the compression force due to compression force in a singly reinforced section. So which is 0.36 FCK B into I need to work out actual depth of neutral axis. Na? So I can write into XU. Should not write XU max because I am interested to work out the actual depth of neutral axis. Need to find the actual depth of neutral axis. So I had just mentioned XU plus C2. What is this C2? C2 stands for compression force. C2 stands for, can say, 1 second. Compression force only. Compression force developed in compression steel. How you can work out the compression force developed in compression steel? So please excuse me, I'll be back in a minute. So please, I'll be back in a minute. Sorry, bros. Uh, so yes, 1 second. Right. So shall we start the session? I mean, shall we? Sorry about that small disturbance, brother. Okay. right? Let me start. So here in this step number 3, when xu is less than xu max, it is called as under reinforced section. You can work out. I mean, sorry, I need to complete this step number 2. Na? So coming to what is this C2, brother? C2 stands for compression force developed in compression steel, right? T2 stands for compression force developed in compression steel. How you can work out the compression force developed in compression steel? Design stress in compression steel or not the stress developed in compression steel multiplied by area of steel in compression. So I can write FSC into ASC. So this is what we work out. Total compression force C1 plus C2. It is equal to total tension force. What is the total area of tension steel? The total area of tension steel is AST 2, and generally we consider tension steel has got yielded. When tension steel has got yielded, the design stress in tension zone is 0.87 times of Fy into AST. So from this one, definitely if you take this equation, brother, 1 second, if you take this equation, okay, you know FCK, you know B, you don't know X. You need to work out the actual depth of neutral axis. Step number 2 is actual depth of neutral. FSC will be given to you in the problem. Like a hint will be given, like the compression steel is yielded. If compression steel is yielded, then then I can write FSC may be design stress in compression steel is when compression steel is yielded, which is 0.87 times of F5. So FSC is nearly equal to 0.8 times of F5 if compression steel is yielded. If compression steel is yielded, right? So you worked out XU from step 2 and you worked out XU max in step 1. This is step 2. This is step 1. When, let us suppose, if you finally our interest is to find out the moment of resistance of the section. So how you can work out the moment of resistance of the section? When xu is less than xu max, for example, when xu is less than xu max, it is called as under reinforced section, right? In such case, to work out moment of resistance, I need to use xu to work out moment of resistance. To work out moment of resistance, generally I can write either compression force into lever arm, but unfortunately the total compression force is again divided into compression force C1 and compression force C2. I hope if I just want to show you with the help of this sketch, right? I hope you are able to see this sketch. This is already given. Maybe if I rub the screen here, this is D dash. Right. Now you tell me how you can write total compression force into equilibrium if I take from tension zone, right? So if I take from tension zone, right? So this compression force C1 total I can write total I can write mu is equal to limiting moment of resistance. I can write as compression force C1 into lever arm L1. This L1 plus in addition to get total compression force, not only C1 is required, C2 is also required. So I can write C2. So about this tension steel, the compression force is C2 into lever arm is L2. So C2 into L2. Now you tell me how you can work out this compression force. You already know compression force C1 0.36 FCK B into XU. You need to use XU only. So into D minus 0 point. I mean lever arm. What is this lever arm L1? Lever arm L1. What is this lever arm L1? This is effective depth D. Effective depth D minus 0.42 X. This depth. So this distance will be D minus lever arm L1, which is D minus 0.42 times of XU. This is C1. I can write this is uh, this is C this is totally this is C1, this is L1, so plus, I need to write C2 into L2. So how you can write C2? So the the compression force, the compression force in compression steel, which is FSC into ASC. So I can write C2 as FSC into ASC into Libram L2. How you can write this Libram L2, brother? So this depth is small d, and this is effective depth for compression zone, which is d dash. So this Libram L2 is d minus d dash. Can we write in this way? D minus d dash. So I can write into d minus d dash, isn't it, or not? So if you work out this way, this is the thing. I had used XU only by the time when XU is less than XU max, I worked out from the basics like total compression force into Libra. But total compression force are two. One is C1 and another one is C2. So I had used C1 into by using Varigna's principle to get moment of resistance of total compression force, moment of resistance of individual compression forces C1 and C2, moment of resistance summation I had considered by using Varignon's principle, which you might had learned in engineering mechanics, right? Same stuff I had used. So if you had done this one, maybe I can say the same stuff as an equation I had shown it here. So one second, let me show that. So the same stuff I had shown as an equation. So based on compression forces, if you had worked out this lever up, okay. So it is C1 into L1 plus C2 into L2. C1. So I can write 0.36 FCK B into X into L1 D minus 0.42 XU. This is L1. C2 FSC into ASC. This is C2. L2 D minus D dash. How we had written this one? I can say from stress block figure of doubly reinforced section DRS. We had written this, isn't it? Now, some people will come and say, like, sir, let us suppose if XU is the greater than. Some people will also say, like, sir, instead of writing compression force into lever, shall I write tension force into lever? Right? If I want to write the tension force into lever, here how many tension forces are there, brother? Here also two tension forces are there. So it is not a wise idea to write it as tension force into Libra. So coming to tension force into Libra, I can write it as tension force T1 into L1, T2 into L2. Coming to T1, the area of steel is AST1. Coming to T2, area of steel is AST2. Do you know separately the total area of tension steel? Do you know separately what is area of steel AST1 separately? What is the area of steel AST2 separately? So in this case, breakup of main steel into AST1 and AST2 is not known, right? I cannot write AST1 and AST2 separately. So in such case, moment of resistance equation based on compressive forces only are used and not based on tensile forces. So this cannot be used. This is not possible to work out practically. Not possible to work out practically. Is that okay? Right. Now, some people will say like, sir, you had written the moment of resistance equation when XU when XU is less than, I hope you are able to see, when XU is less than XU max for under reinforced section, you had written the moment of resistance equation. Let us suppose, sir, when the type of section is balanced section, sir, when it is a balanced section, when XU is equal to XU max, when XU is, this is from step 2, this is from step 1, right? When XU is equal to XU max, you can judge the type of section as balanced section. So how you can write that moment of resistance? The moment of resistance is equal to limiting moment of resistance. So instead of XU, just use XU max instead. So how you can write that XU max, brother? So we can write that XU max. How you can write that one? How you can write that one? Limiting moment of resistance, maybe mr is equal to compression force C1 into L1 plus C2 into L2, but instead of XU you need to write XU max. That is the one and only difference, right? So what is that compression force C1? I can write it as 0.36 FCK B into XU. Generally I iterate But as XU is equal to XU max, now I can write XU max into L1 D minus 0.42 times of XU. But as XU is equal to XU max, I need to write here as XU max. So moment of resistance of a singly reinforced band section plus moment of resistance of compression steel. So what is the moment of resistance of compression steel, which is C2 into L2? What is that C2, brother? C2 is FSC into ASC into L2. What is that L2? Lever arm to D minus T dash. So this is how I can work out the moment of resistance, just like that of the previous formula derivation. But instead of XU, I substituted here XU max. That is the only difference. So I hope clearly you are able to see here in the previous slide. Here it is XU. This is XUs, right? Here it is XUs. But here instead of XUs, I am replacing these XUs by XU max. That is the only difference to work out for balanced section. Let us suppose some people will come and say like, sir, our section is not a under reinforced section or balanced section, sir. For our section XU is greater than XU max. From which step I worked out XU max? From step number 1. From which step I worked out XU? From step number 2. So I can say these are from step 2. This is step 1. So when XU is more than XU max, in such case the section is nothing but over reinforced section. For over reinforced section, what we can do, in case of over reinforced section, such type of designs are already prohibited as per IS 456. So I can say as per IS 456 2000, design of a section, design of doubly reinforced section is prohibited. What is the reason why the design of doubly reinforced section is prohibited? Any reason for that one? Since the failure is brittle failure. Since the failure is in concrete for over reinforced section, since one second, since the failure is in concrete for over reinforced section, I can say definitely like, I can say definitely like uh, I can say definitely like the moment of resistance. If any existing beam is found to be over reinforced section, reduce the code says as so as per design of ORS is prohibited. So in such case, if any existing structure is found to be as over reinforced section, how to find out moment of resistance of the section? If an existing beam is found to be a over reinforced section, reduce its load or moment carrying capacity to that of a balanced section. So what is the moment of resistance of a balanced section? The same thing by using XU max. So in such case, the moment of resistance, how you can write? Compression force C1 into L1 plus C2 into L2. But you need to use XU max. So please be aware. So design of over reinforced sections is not recommended. But before IS 456 2000, if you find any structures are designed as over reinforced sections from calculation, then its moment of resistance can be worked out as if the moment of resistance is just like that of a balanced section using XU max. So we can write clearly, a second, is compression force C1. How you can write compression force C1? 0.36 FCK into B into XU into lever arm D minus 0.42. I can say XU, but here instead of XU, they are asking you to replace with the help of XU max. So I need to write as XU max. Here also I need to write as XU max plus T2. I can write as FSC into ASC into lever arm L2 T minus T dash. So using this equation, we are able to work out that. Is it okay? Right. This is how you can work out the This is how you can work out analysis of doubly reinforced section. The theory part is completed. So let me directly work out the problems. Is that okay, brothers? Shall I directly work out the problems on doubly reinforced sections? Yes, moving to the problems of doubly reinforced sections. So I hope you are able to see a concrete beam. One second. A concrete beam has 350 millimeter width and 700 millimeter effective depth. 350 millimeter width and 750 millimeter effective depth. So I can say B is 350 millimeter and small d effective depth na, so it is small d, it is 700 millimeter. It is subjected to a superimposed bending moment of 300 kilonewton at service conditions. So the bending moment is 300 kilonewton at service conditions, but I want factored bending moment. So what is the factored bending moment, which is equal to service bending moment into partial safety factor for load. What is the partial safety factor for load for superimposed loads? It is 1.5. This I already mentioned in first class. Service bending moment is 300 into 1.5. So if you work out, it is 450 kilonewton meter. And metals used are M15 and Fe 4 and 5. So FCK is 15 megapascal and yield strength of steel is 415 megapascal with the stress in compression steel FSC. So let me write here clearly stress in compression steel, which is 353 points megapascal Newton per millimeter. The amount of tension and compression steel. So they are expecting area of tension steel AST, which is AST 1 plus AST2 if it is any, right? That is, they are expecting that AST1 and AST2. If AST2 is existing, I need to use that one. If there is no AST2, I need to forget about that, right? And they are saying amount of tension steel and compression steel. They are saying compression steel also means the AST2 will also be there. So ASC will be the question, AST will be the question, and they are expecting use the effective cover to compression zone, so and tension zone. So for effective cover for compression zone or tension zone, is D dash is 50 millimeter, right? This is how it was given, and the question is a design question. To work out with respect to design question, I need to compare between MU and MU limit. I hope you know the first step. Is it or not? I need to follow. This is a design question because the question is asking us to find out AST and ASC. So this is a design problem. So the steps for design problem and analysis problem are different. This is a design problem. I just want to write. So this is a design problem, and if it is a design problem, right? Okay. Now when it is a design problem, what is step one, brother? Find out MU limit. MU limit. So when you take the grade of steel is Fe4 and 5, MU limit is limiting moment of resistance of a singly reinforced balanced section. MU limit, which is 0.138 FCK PD square. So which is 0.138 FCK is B is 350 into effective depth square, which is equal to, if you see, is 355 into 10 to the power of 6 Newton milli. In terms of kilonewton meter, it is 355 kilonewton meter. So you can understand, like after this one, if I compare, so for this problem, if you see, MU is equal to 450 kilonewton meter is, I mean, the factored maximum bending moment is more than limiting moment of resistance of a singly reinforced section, right? Limiting moment of resistance of a mu limit of a singly reinforced section. So in this case, you can understand I need to design it as a doubly reinforced beam only, right? I can say here need to take design as a doubly okay. Need to design as a doubly reinforced beam. Okay. So if I want to design as a doubly reinforced beam, first, I mean, after in step number two, I need to work out AST2, AST1, right? So maybe I can say like step two, finding out AST1, area of uh, tension steel corresponding to a singly reinforced balanced section. Reinforced balanced section is what we teach you at the time of procedure, right? So can you work out how you can work out this AST1, brother? I hope AST1, for corresponding to AST1, the moment of resistance is mu limit. So I can write mu limit is equal to, so this is T1, tension force T1 into L1. Tension force T1 into L1 is 0.87 Fy into AST1 into leveram L1. The leveram L1 is D minus 0.42. I need to write XU. But here I consider that AST1 is the area of tension steel corresponding to singly reinforced balanced section. For balanced section, XU is equal to XU max. So what is the value of limiting moment of resistance, brother? Limiting moment of resistance, we already worked out it as 355 into 10 to the power of 6. Is 355 into 10 to the power of 6, and F5 yield strength of, yield strength of steel. What is the yield strength of steel that was given in the problem? 4 on 5. I need to work out this AST1. What is this effective depth? 700, right? So coming to XU max, which is 0.48 times of effective depth, is 700. This is XU. If you substitute in this equation all this stuff, you work out AST1. What is the value of this AST1? 1759.3 millimeter square. But this is not the question. They are expecting total area of steel, not just area of steel corresponding to singly reinforced balance section. They are expecting total area of steel. How to work out this total area of steel? Maybe I can work. I can definitely work out from step three. From step three, I can work out AST2. How can I do that? So I can write here finding AST2. So how you can do that? What is the remaining moment that is resisting this? That is resisting this area of steel in tension to. Right? I can say the moment is mu minus mu limit. Mu minus mu limit. Mu minus mu limit is equal to 0.87 Fy. When you try tension force T2 into L2 is 0.87 Fy into AST2. This is tension force T2 into leveram L2 D minus D dash. So in this equation, if you see, if I substitute everything at mu, which is 450, as mu limit 355 into 10 to the power of 6 is 0.87 Fy. Fy is 415 into AST2 into, I don't know this, right? This is the one and only unknown in this equation, into D. Effective depth is 700. D dash is, I think it is 50. So when you do this, when you work out this equation, you are able to work out AST2. So what is that value of this AST2? 404.8 millimeters. How you can define this AST2, brother? Some people will also ask for definition. AST2 is the area of tension steel which resists the remaining extra moment mu minus mu limit. I can write in this mu minus. Okay. So I use this moment to be resisted is mu minus mu limit. For that one, what is the area of tension steel to need to provide 404.8. So coming to this question, I hope can I rub the screen, brothers? So can I rub the screen? So let me rub the screen here, right? There is all ink on the slide. Let me rub the screen. So coming to the question, they are expecting total area of steel, maybe step 4. What is step 4? In step 4, I need to work out total area of steel, total area of tension steel. This is AST1 plus AST2. What is this AST1? Which is 1759.3 plus 404.8. If I add up this one, it is 2164.1 millimeter square. This is AST2. But they are expecting given area of compression steel also, if you see, right? They had given even the area of compression steel also. So maybe step 5, working out compression steel. How you can work out compression steel? The compression steel is used to resist a moment of mu minus mu limit. So I can write the moment of resistance which can resist this compression steel is mu minus mu limit. Okay, which is equal to, I can write this as compression force C2 into L2. Compression force C2. What is this compression force C2? How you can write? Which is stress developed in compression steel into area of steel in compression zone. FSC into ASC into Libram L2. The Libram L2 is D minus D dash. This I had already mentioned you at the time of stress block. Clearly, I had derived this. So coming to FSC, people had a doubt like, sir, how to work out this FSC? I think this problem in this problem that FSC is also given. I hope if I rub this one, if I erase all the ink here, FSC is how much? 353.7 megapascal. It was clearly mentioned in the problem. So I can write FSC. I can use this as 353.7 megapascal. AC is the unknown question mark. D 700. D dash T. Mu minus mu limit. How I can write about mu? Mu is 450. That is the maximum bending moment to be resisted. Where the section is 450 and the limiting moment of resistance of a singly reinforced section is 355 into 10 to the power of 6, which from this equation, I hope you know this is 353.7 into ASC into 700 minus 50. The one and only unknown is this ASC, the one and only unknown. So can you work out this ASC, brothers? So if you work out this ASC, area of steel in compression, ASC, it is equal to 413 millimeter square. Right. So if you refer to the options, total area of steel in tension zone is how much? 2164.1. Total area of steel in compression 413. So you can see these two options, whether these two options are matching with the whether these two values are matching with the options or not. Let me see. Let me see. So coming to area of steel in tension zone, which is a total area of steel is 2164, right? 2164 and it is 413. So this is area, total area of steel in tension zone, AST, and this is total area of steel in compression zone, ASC. Nearest values 413, but here it is 412. So I can pick option C is the correct one. So like that I can pick directly, right? This is AS, total area of steel in tension zone, and total area of steel in compression. So shall I move to the next problem, brother? Right? Can I move to the next problem? Right? Moving to the next problem. I hope if you see this problem, a doubly reinforced. I, this is a problem. In this one, they are expecting depth of neutral axis. So this is a problem based on analysis problem, not design problem. Steps for analysis is different, steps for design is different. Na? You need to use the steps for analysis. So coming to this one, a doubly reinforced rectangular concrete beam has a width of the rectangular concrete beam is 300 millimeter, and with an effective depth of, that is small d, effective depth is 500 millimeter. The beam is reinforced with 2200 millimeter square of steel in tension. So that they are saying AST, area of steel in tension zone, it is 2200 millimeter square, and area of steel in compression zone, ASC, 628 millimeter square. The effective cover for compression steel is 50 millimeter. Is D dash is 50 millimeter. Assume that both tension and compression steel are yielded. So that means when both compression steel, they are saying both compression steel and tension steel are yielded. So when compression steel is yielded, the stress in compression steel, FSE must and should be written as 0.87 times of F5. I just want to say that, and I can say why I am writing FSE is 0.87 times of F5, because they are saying like both tension steel and compression steel are yielded. So they are saying compression steel is yielded, na? So I can say here, when compression steel is yielded, I can say here I can write both tension and compression steel are yielded. When both tension and compression steel are yielded, by the time I can write this stress developed in compression steel is 0.87 times of F because compression steel is yielded. So it is equal to design stress in uh, design stress of steel. Design stress of steel. This FSC is equal to actually stress developing in steel. It is equal to design stress of steel, right? So, and if you take this one, the grades of concrete and steel are M20 and Fe250. So they are saying FCK is 20 megapascal, and yield strength of steel is 250 megapascal. They are saying the stress block parameters, they are saying use the stress block parameters rounded off to first two decimal points as per IS 456. So you are free to use these stress block parameters as per IS 456. As per IS 456 stress block parameters, you can use the same compression force, same tension force, like that. So what is the actual depth of neutral axis? What is the actual depth of neutral axis? Oh, this is the question. So if this is the question, now you tell me, so to work out the actual depth of neutral axis. So in the analysis problem, they are expecting actual depth of neutral axis. And they are expecting you to work out actual depth of neutral axis, that can be always be worked out from total compression force is equal to total tension force. What is the total compression force? Here there are two steels are there, compression steel and tension steel. So the compression force resisted by concrete plus compression force developed in compression steel is equal to total tension force T. This is how we can write. So how you can write this compression force C1, as they need to find out the actual depth of neutral axis. The compression force C1 It is compression force resisted by concrete. By compression concrete. Compression force in compression concrete. C2. Compression force in compression steel. So what is the compression force in compression concrete? So which is 0.36 FCK B into the actual plus C2. So how you can write this C2 compression force in compression steel? Stress developed in compression steel FSC into ASC to ASC is equal to total tension force. How you can write this T? T is equal to total tension force. How you can write the total tension force, man? The tension they had clearly mentioned the tension force is yielded. So I can directly write the permissible stress in tension steel, which is a design stress in tension steel, which is 0.87 Fy. I can write into total area of steel AST. This is how we can write. So from this one, I the one and only one unknown is XU is the one and only one unknown. So just try to substitute. What is the value of FCK, brother? Uh, the value of this FCK is 20 megapascal. This B, the width of steel is 300. FSC, which is 0.87 times of F5. 0.87 times of F5 is they had used is mild steel. So 0.87 times of 250. ASC, area of steel in compression zone. What is the area of steel in compression zone? What is the area of steel in compression zone? I think it is given here. It is 628 is the steel area in compression zone. So multiply, let me write here into 628. 0.87 Fy is 250. And area of steel in tension zone. What is the area of steel in tension zone? 2200 is the total area of steel in tension zone. Here, one and only one unknown is XU. This is the one and only unknown. Question mark. So this is one and only one equation. The one and only unknown. You are able to work out that XU, the actual depth of neutral axis is 158.3 millimeter. This is how we can work out the actual depth of neutral axis. And they are expecting you about moment of resistance. You can directly work out by writing C1 into L1 plus C2 into L2. But whether you need to use XU or XU max depends on the type of section finally, right? So moving to the next question. Is that okay? I hope you are able to see this next question, right? The same question, I hope if you see same above question, but they are expecting for the same above question the moment of resistance of the section. How can we find out the moment of resistance of the section? Please guys excuse me, I will be back in a minute, please. Sorry guys. Okay, let me right. Okay, so shall I work out the moment of resistance of the section, brothers? Yes, let me work out the moment of resistance of the section. This is just like a previous problem only. Extension of previous problem I can write. Extension of previous problem. So if you see the extension for this previous problem, okay, uh, they in your previous problem they asked you to find out the actual the depth of neutral axis, but here they are expecting the moment of resistance of the section. So I can say from previous problem, same problem, the value of XU is 158.3 millimeter. Right. So coming to XU max. XU max is 0.53 times of D, right? That the effective depth is 500. So if you see, XU is less than XU max. So that's the reason why I can say it is an under reinforced section. Let me write, it is clearly an under reinforced. It is an under reinforced section. For under reinforced section, I need to use just XU as it is, right? Need to use XU only. I can use XU max for balanced sections, and for over reinforced sections to find out moment of resistance, I can use XU max. Uh, but for under reinforced sections, I need to use only XU. That is the common thing that you already know, right? So let me work out the moment of resistance. Can I use the next slide to work out the limit? Can I use the next slide to work out the ultimate moment of resistance? Yes. So MU, which is ultimate moment of resistance. How you can work out that MU, brother? You can work out that MU clearly by writing compression force C1 into L1 plus compression force C2 into L2. Use only XU. Compression force C1, which is the force resisted by compression concrete, 0.36 FCK V into XU into L1 lever arm. So lever arm for lever arm between force in compression concrete and tension steel AST1, which is D minus in case of a singly reinforced section, D minus 0.42 XU, right? Plus C2. C2 stands for force in compression steel, which is developing stress in compression steel, FSC into area of steel in compression. FSC into ASC into, I need to write it as T2 into L2. How I can write this leveram L2, brother? I can work out this leveram L2. Definitely, how I can work out that leveram L2, which is D minus D dash. This I had already teach you. Right? So if I just substitute all these things, FCK, how much is 20? V 300 millimeter. XU value, I think we had already worked out from your previous problem, which is it is clearly given as XU as 158.3 from the previous problem. I had already worked out. It's a linked statement question, right? So which is 158.3 I can write. So I can write here 158.3. So effective depth, that effective depth is 500, right? XU is 158.3, right? FSC, stress in compression steel. What is that stress in compression steel? They had mentioned clearly what is the stress in compression steel. They said like both I can say assume that both the tension and compression steel are yielded. This compression steel has also got yielded, so I can say FSC is 0.87 times of F5. I can say 0.87 times of F5. What is the grade of steel that is used? It is mild steel, na? So which is Fi is 250. I can write here clearly. Fi is 250 megapascal. And area of steel in compression zone, ASC. How you can work out ASC? Area of steel in compression zone. What is that ASC value? That ASC value is was clearly given. It is 628. It seems it is 600. I think it was given 628 is for steel in compression zone, and for steel in tension zone 200 2200 millimeters square for steel in tension zone. I need to use 628 for steel in compression zone. So D, the effective depth, I think it is 500 is given. Effective D dash, effective cover for compression zone. Maybe I can write as 50, right? It is not maybe, it was clearly given in the problem, right? So if I work out that one, definitely you will end up with 209.69 into 10 to the power of 6 Newton millimeter. So if you can simplify that as definitely 209.63 kilonewton meter. Right? This is how you can work out, and it's a numerical answer type, it seems, or not numerical. 209.69 na. So which option you can pick? You can pick option B, 209 point something. I got 6. So this option given is 209.2. This is the only nearest answer as per the given options, right? It's not a numerical type. You can pick the option. So I can pick option B, right? So shall I move to the next question? Is that okay? So moving to the next problem. So this is the next problem. I hope you are able to see this is the next problem. A simply supported beam of 8-meter effective span. You can take a simply supported beam and take a simply supported beam of 8-meter effective span. Okay. RCC rectangular beam of 300 millimeter by 500 millimeter. The width overall, so I can say B by D. So B is how much? It is 300 millimeter. Overall depth, it is capital D, it is 500 millimeter. Overall depth is reinforced with 4 numbers of 25 millimeter bars at an effective cover of from tension phase. So they are saying for tension phase it is 37.5. So effective depth is maybe I can write 5, not maybe, I can write definitely 500 minus the effective cover in tension zone. What is the effective cover in tension zone? 37.5. So if you work out this one, it's 462.5 millimeter, right? So they are saying that it is this overall section is reinforced with 4 numbers of 25 millimeter bars in tension zone. So they are saying AST, area of steel in tension zone, 4 bars of 25 millimeter diameter. So I can write 4 into 5 by 4 into 25 square. I can write in this. It will end up with 1963.5 millimeters. Area of steel in compression zone, ASC. How you can work out this ASC, area of steel in compression zone? Right. Can you see this one? 2 bars of 16 millimeter diameter are used in compression side. So I can write 2 into 5 by 4 into 16 square. If you work out this 402.124 millimeters with an effective cover. They are saying effective cover of 50 millimeter compression fiber. What is the notation that I had given for effective cover on compression fiber on compression side? It is nothing but D dash. D dash is 50 millimeter. Millimeter. Ultimate moment of resistance. They are expecting ultimate moment of resistance in kilo. So how you can work out this ultimate moment of resistance? They are expecting mu. They are saying FSC is equal to 0.8566 times of F5. And coming to F5, it is Fe4 on 5. So I can write into 4. So if I write, this is 355.489 megapascal, which is Newton per millimeters. So this is how we can do. Now after this one, okay, I need to work out mu. I need to. This is an analysis problem because I know they are expecting you to work out ultimate moment of resistance. So it's an analysis problem. When it is an analysis problem, what is step number one? In case of analysis problem, I need to find out XU max. Step number one. Step two. Step number one, XU. Step two, XU max. Compare XU and XU max and judge the type of section. That is step number three. Step number four, write MU equation. C1 into L1 plus C2 into L2. Whether you need to use XU or XU max, in that one you need to judge that. Just the problem is over, right? So which is very simple only, right? Let me work out that. One second. One second. Let me work out this here. Okay. So they had given that steel is Fe 415. Step one. Maybe some people will also ask all the steps. That's the reason why I'm writing with steps. Step one, which is XU max. What is XU max for Fe 415? It is 0.48 times of D. So which is 0.48 times of effective depth. What is that effective depth? We got 462.5 millimeter. So if you work out, it is 222 millimeter, right? So step one. Step two, I can say you need to find out the actual depth of neutral axis. Find actual depth of neutral axis. When I want to find the actual depth of neutral axis, I can write total compression force. I can write total compression force is equal to total tension force. Clearly, I can write what is the total compression force. I can write C1 plus C2 is equal to T. What is C1? Compression force is said by compression force developed in compression concrete, which is 0.36 FCK B into, they are expecting you to work out actual depth of neutral axis. Let me write into XU. So plus C2, it is the compression force developed in compression steel, which is FSC into ASC. Total tension force. What is total tension force? They had a clearly given, like uh, they had clearly, I think like they had clearly given in the problem the compression the compression steel stress developed in compression steel is 0.8566 F5. Generally tension steel is yielded. When tension steel is yielded, right? So I can write F 0. When tension steel is yielded, the stress the design stress in tension steel is 0.87 times of Fy into AST. This is how we can write. Now 0.36. What is this FCK? FCK is to grade 25, B is 300 into XU. XU is the unknown plus FSC. FSC is how much? It is 355.489 into area of steel in compression zone, which is 402.124. This is equal to 0.87 F5, which is Fe415 into area of steel in tension zone 1963.5. Whatever may be the given content or given data, I just substituted in this equation, nothing else. I just substituted the data in these equations, nothing else, right? So after I do, hi Suram Rakesh, hope you are fine, right? How are you, brother? When I work out, so in this one, the one and only unknown in this equation, the one and only unknown is XU is the one and only unknown. So if you work out that XU is 209.62 millimeter. If you want to compare XU and XU max, right? You want to compare XU and XU max. What is the relationship between XU and XU max? XU is lesser than XU max. So I can say as XU is less than XU max, I can say what will be the type of section? Type of section is under reinforced section. Let me write that. Type of section is under reinforced section, right? So when it is under reinforced section, if you see the question is all about I need to work out the ultimate moment of resistance EMU. So how you can write that ultimate moment of resistance EMU? I hope you already know, right? Maybe this is step 3, I can write here. This is step 3. Coming to step number 4, I need to work out the ultimate moment of resistance. To write that ultimate moment of resistance, I just want to rub the screen. If you please excuse me, can I rub the screen here? The question is about ultimate moment of resistance. I need to write that equation from the stress block directly and just need to substitute. That's it. And you should understand as XU is less than XU max under reinforced section. Na? So I can say use XU only in moment of resistance equation. In MR, moment of resistance equation. Only use XU. Don't use XU max. Okay. So can I rub the screen? Brother, brother Suram Rakesh, can I rub the screen? Okay. Right. Okay. Now coming to ultimate moment of resistance. Ultimate moment of resistance, people usually call it as MU. Generally, it is compression force C1 into lever arm L1 and plus compression force in compression steel C2 into lever arm L2. This is what I teach you. And coming to this compression force C1, I can write as 0.36 FCK into B into X is XU, right? So into XU, this is compression force C1 into lever arm L1. What is lever arm L1 for a singly reinforced section, which is D minus 0.42 XU plus C2. That is the compression force in compression steel. What is the compression force in compression steel? FSC, stress developed in compression concrete into ASC into L2, lever arm L2. How we can work out that lever arm L2? That is D minus D dash. Dear brother Soram Rakesh, I had already derived these equations at the starting of this today's session. With the help of stress blocks, I had shown these equations. So every time it is difficult for me to show again the stress block. So I had derived this one, these equations already. Okay, so just after this session is over, if you are not know how I am writing this equation C1 into L1 plus C2 into L2, you can refer to the starting session of you can refer to the starting of the today's session. Okay, for the first 1 hour, the theory part is over, right? Okay, if you do this one, so let me substitute, brother. So FCK grade of concrete. The FCK grade of concrete in the given problem is 25 megapascal, 25 Newton per millimeter square. The width of the beam. It is I mean to say the width of the beam, which is 300 millimeter, and it is XU. XU stands for the actual depth of neutral axis. The actual depth of neutral axis, if you see, we got it as I hope 209 point something. We had already got. Sorry, 209 0.62 we already got. And D effective depth. What is that D effective depth? Effective depth is 462.5 and XU same 209.62. FSC FSC, it was given in the problem like 0.8566 times of Fi. We had worked out that one. If you see, FSC stress developed in compression concrete is given as 0.8566 times of Fi. If I work out this 355.489, right? I am just substituting that, which is 355.489. And ASE, what is that area of steel in compression zone? The area of steel in compression zone, which is 402.124, 402.124, and effective depth D. Effective depth D is 462.5. D dash, that is the effective cover in compression zone. What is the effective cover in compression zone? That was given 50 millimeter. So if I work out this one, finally I will end up with the answer of 270.9 into 10 to the power of 6. I will end up with Newton millimeter. But if you see the questions and options, the answer was given in kilonewton meter. So which is 270.9 kilonewton meter. So this is the final answer, which is matching with, if I hope it is a numerical answer type, na, they are expecting the answer in kilonewton meter. So you need to mention it as 270.9. This is how you need to mention 270.9. Is that okay? Just you need to type 270.9, right? Yeah. Kilonewton meter, because they are expecting the answer itself in kilonewton meter. There is no need to type kilonewton meter here. So can I move to the next problem, brother? I mean, last and final problem. Can I move to that problem? So I hope you are able to see this question. Can you see this question? A simply supported beam of 8-meter effective span. I hope same problem, just like that of previous class. I mean, question 5 and question 6 are linked statement questions. So same previous problem. Data is same as that of previous problem, and data is same as that of previous problem. In such case, yes, right. So you are free to use that data, right? Okay. So if you see a beam, a simply supported beam of 8-meter effective span. Let me take 8-meter effective span. Center to center, 8-meter effective. Okay, right. RCC rectangular beam of width. What is the effective width of the beam? The RCC rectangular beam of width 300 meters. So I can say this B is 300 millimeter, and overall depth is 500 millimeter. If you people are expecting the effective depth, overall depth minus I can say effective cover in tension zone, which is 37.5. So 500 minus 37.5, read that problem. So the same thing I already explained in previous problem. The data is one and same, but in the previous problem they are expecting moment of resistance, but in this problem they are expecting superimposed live load. What is the superimposed live load that we can apply? That's both the data is one and same, but the question that was asked for the data is different. Okay. So yes, they are saying M25 grade of concrete, FCK, is 25 Newton per millimeter square, and yield strength of steel is Fe 4 and 5 grade. And they are saying two bars of 16 millimeter diameter bars are used on compression side. So a compression side ASC will be 402.124 millimeter square. Area of steel in tension zone AST. If you see 10 on tension side, four numbers of 25 bars are there. So which is 4 into pi by 4 into 25 square. This I already teach in your previous problem, because the data is one and same. The same thing I am using. So AST, which is 1963.5 millimeter square. Okay. So far they are saying the D dash. What is the D dash? Effective cover of 50 millimeter from compression fiber. So effective cover for compression fiber D dash. What is that effective cover for compression fiber? D dash is 50 millimeter. Okay. In this case, so they are expecting superimposed live load the beam can carry with the load factor as 1.5 for dead and live load combination. And they are expecting you to take the dead load also. How you can work out the dead load? Density of concrete multiplied by cross section area. So if this is the thing, from your previous problem, I can say the same problem. If you refer here, ultimate moment of resistance is 270.9 kilonewton meter. So I can say mu ultimate moment of resistance is mu is equal to 270.9 kilonewton meter. If you people are expecting service moment of resistance, the ultimate moment of resistance na, if you people are expecting working or service moment of resistance, how we can work out the working or service moment of resistance? Working or service moment. How we can work out working or service moment is equal to mu by load factor. Load factor is gamma f, and I can say 270.9 by 1.5. It will be definitely 180 kilonewton meter. 180 kilonewton meter. So on this on this one total UDL, I need to consider generally dead load. Dead load intensity is WD and live load intensity is WL. I need to consider, right? So I need to consider dead load and live load are intensities. The maximum bending moment is WL square by, which we call it as W here. Dead load intensity plus live load intensity into 8 square by 8, that is equal to service moment. I can do service moment is how much? It is 180 kilonewton meter, right? From that one I am able to work out the superimposed live load, right? So can I work out that one? So first of all, let me work out dead load here. So dead load intensity, dead load intensity. How you can work out the dead load intensity, which is WD? We can write it is gamma C. That is the density of concrete, which is gamma C into gross cross section area B into D. Then we will get everything in terms of kilonewton per meter. What is gamma C? That was given in the problem. I mean, density of concrete is 25 kilonewton per meter cube. So let me use 25 kilonewton per meter cube into cross section area. What is the width? Width is 300 millimeter. Effect overall depth is 500 millimeter. So it is 0.3 meter by 0.5 meter. This is given. So in such case, the dead load intensity is 3.75 kilonewton per meter, right? So coming to the question is, I need to find out what is the maximum superimposed live load that I can apply. So what is the live load intensity that I can apply? Always for the condition of safety, maximum developing bending moment should be less than maximum developing service bending moment should be less than or equal to maximum service moment. So if you see what is the maximum developing service moment, brother, so it is dead live load intensity plus dead load intensity into L square by 8. This should be less than maximum service moment, which is 180.6 kilonewton meter. What is this live load? This is the question mark. I need to find out this, right? Service moment, service live load, I will superimposed. They are expecting here superimposed live load, which stands for WL. I need to find out that one, right? So can you work out this WD answer? That WD answer I had already worked out, and it is for 3.75 kilonewton per meter. So I can write WL plus 3.75 into what is the span, effective span of the beam. The effective span of the beam is 8 meter. Now 8 square by 8 value should be less than or equal to 180.6. If you do this live load intensity, you should be less than or equal to 18.82 kilonewton per meter. So if you are expecting here, what is the see here, what is the superimposed live load the beam can carry? At max, the beam can carry a superimposed live load of 18.8, right? So therefore, superimposed live load the beam can carry, it is equal to 18.82 kilonewton per meter. So if you see this problem, there are no options are there, and it is a numerical answer type. So in this blank, I should type this answer as 18.82, and this they are expecting the units in kilonewton meter. So I need to type it as 18.82. That's it, right? So I covered all the models in doubly reinforced sections also. So before I end the session, I just want to convey there is there is paid courses also happening in an academy, also in an academy plus. So if you are really an aspirant of GATE or ESE or any other competitive examination, then I can definitely recommend you to take the paid course. Coming to the price of that paid course for 12 months course in an academic plus, the cost after 10% discount is 27,225. If you are a student of third year or second year student, I can recommend you this 24 months course, which is costing 39,600 after 10% discount. To get 10% discount, brother, you are bound to use this code VT10. When you are able to use this code VT10, then only 10% discount will come. So if you don't use faculty referral code, you will miss 10% discount also. So please be aware. And if you want to follow me in an academy learning app, you can use this link. Use this link to follow me in Unacademy learning app. So first of all, if you didn't till now, if you didn't download an Unacademy learning app, please download that one, because so much of free content is also happening. And if you want to purchase any paid course also, that Unacademy learning app is required, right? I just want to convey every day my class is happening in this GATE 2021 rankers batch by 11 a.m. using concept through questions. Every day my class is happening by 11 a.m. except on Saturday and Sunday, except on Sunday and Monday, right? So before I end the session, I just want to say you are getting this for free of cost, right? So if you say the same thing to your friends, those people will also get benefited. It's a mutual benefit for you and to your friends also. So please share these videos to your friends also who are in the same class, maybe your college mates or anything. So I can recommend you, like, so much of free content is also happening in Let's Crack Gate and ESC Civil YouTube channel. So I can recommend you to subscribe to this channel. When you subscribe to this channel, the upcoming classes for free of cost in this channel will be notified to you. Don't forget to press the bell icon. If you press the bell icon, okay, then notifications of the videos will be notified to you, definitely. And I just want to convey one more thing, like I already started Telegram group, and the name of the Telegram group is this Unacademy underscore civil engineer Tilak. Okay, if you want to come down to my Telegram group, directly use the link below, which is given below. Use the link which is given below, Unacademy underscore civil underscore engineer underscore Tilak. If you press this link, this is the link. If you press this link, it will redirect you guys to my Telegram group. And if you had any doubts, you can post your doubts directly in the Telegram group. If it is structural doubts, I will respond. If it is a non-structural doubts, the other faculty who are in that group will respond to you guys. Okay, right? And if you want to take a subscription for paid course in an Academy Plus, use the code BT10 to subscribe to take the subscription of paid course in an Academy Plus. Okay, thank you. End of the session.